Now let's talk about types of vectors. Okay. So first and foremost is called as position vector. What is a position vector? So if I take a Cartesian system, X and Y, okay, and this is a position of a body. So if I draw something from the actual origin, okay, here we are talking about actual origin. So this is a position vector for this point. So let's say this point is A. So I can name it as a RA vector. Okay, let me draw it bigger. So this is RA vector. Okay, and let's say there is a point B. So for this point B, this is another position vector which I can mention it as RB. Okay, so RB, the length, the magnitude, I know how to find the magnitude. It actually tells the length of this, and the direction is actually shown to you here. Okay, so these are position vectors which are actually pointing to a position. Okay, right from this position vector, the second thing that we can understand is the displacement vector. What is a displacement vector? Let's say a body from point A moves to point B. Okay, so what happens is there will be a direction from this to this, and this is called as the displacement vector. Okay, I can denote it as delta R vector. Also, I can denote it as R going from 1 to 2, like this. Sorry, not 1 to 2, AB, A to B. I can denote it as that as well. Okay, good. Now comes null or zero vector. This is a kind of interesting thing. When we say zero vector or null vector, a vector which has magnitude 0 and no direction. Now, this no direction is a debatable topic. Okay, some of the physicists think that null or zero vector has zero magnitude. Okay, not an issue, but may or may not have a direction. Okay, from my perspective, from 11th and 12th perspective, or probably till the point we are doing some graduation physics, it will not have any direction. So keep it simple. There will be no direction for this as well. Okay, so no direction and magnitude is also zero. How do you show it? Okay, actually you don't show it, you just put a point here. That's it. So that is how you show a null vector. One of the interesting things about null vector is, what if there is a null vector? Actually, you can write a null vector like this, zero vector. If I add any other vector to it, it gives that vector itself. If I multiply that vector with something, it will be again a zero vector. Got it? Okay. Fourth one. Fourth one is unit vector. This is one of the most important vectors that you will come across each and every time. For this, you need to understand the Cartesian system. How? Let's build a Cartesian coordinate system x, y, and also let's say I have a z. Okay, and I have a point somewhere here, position vector. Let's take a position vector here, and position vector A, this is origin, perfect. So now if we need to actually resolve it to a unit vector, And here anything which is unit vector is actually depicted as I, J, and K. Okay, so A can be represented in some value with I, J, and K. So I think before we understand the unit vector, let's also understand together what is resolution of a vector. So with this will make much more sense to you. So A vector, which is actually mentioned here. So A vector can be represented as some magnitude times a unit vector in x direction, some magnitude in y, and some magnitude in z direction. I, J, and K. Okay, so we actually denote it as a unit vector. What is a unit vector? Nothing. It has a fixed direction and it has a unit magnitude. That means 1. So we use it only to actually denote a direction. Okay, the purpose of unit vector is to denote it as a direction. What we did here is we actually resolved a complicated three-dimensional point vector A into 3 components, separate components. Like AX is the magnitudes towards this X axis, AY is the magnitude towards Y axis, AZ is the magnitude towards K axis. And that is, you can sum it up like this. Okay, this is for Cartesian. We'll not go into how it is done for polar coordinate system. We'll look into when we'll go into detail of coordinate systems. But for example, we can just simply resolve it in three-dimensional space, and we have broken it down into I, J, and K unit vectors. So if I have to say, so I, J, and K, you can simply see I'm putting a cap here. So it is no more denoted as an arrow, it is denoted as a cap. And if you want to find the magnitude of it, it comes out as 1. Make sense? Great. Last one, a bit complicated to understand, which is a normal vector. What is a normal vector? Normal vector actually talks about a surface and a perpendicular to it. So let me actually bring a notebook. So this is a plane surface. Okay, this is now pointing upright. And I want to say that what is the normal vector? Normal vector will point with the head towards top and tail below. Okay, so this is actually a normal vector for this area. Very interesting thing is area actually, if you look into it mathematically, it talks about that area is actually scalar value. Okay, however in physics most of the time in class 11th and 12th, the area is actually a vector quantity. Keep that in mind and it will come very handy when we go into some of the complicated problems of fluids, electrostatics, as well as electromagnetism, and and many other areas. Okay, so normal vector is denoted as n with a cap. Why a cap? Because again, the magnitude of normal vector is equal to 1. It only signifies in which direction this face is actually there. Now let me tilt it a bit. So if I tilt it a bit, the normal vector actually also tilts. So the normal vector changes with the area. Okay, it has to be a plane surface. It may be regular or irregular, but it has to be a plane surface which in which we can put a normal vector. So normal vector is always directing outwards. That completes the types of vectors. The next thing we'll talk about is the classification of vectors. How do we actually categorize, not in fact classification, I should say the category of vectors. How do we categorize all the vectors that we have? Okay,